All right, so we're going to look at um, writing down, formally writing down the information we did yesterday from these polynomials. I don't want you to get frustrated. Normally, this part of polynomials takes a long time before people start like putting the pieces together. We are working on different sections of a giant puzzle. It's going to end up looking like a beautiful picture. But right now we're looking at just a bunch of pieces, and it takes a while for us to get it all together. So don't get frustrated. This is going to go slower than it normally does, but uh, we're going to get there. And it's all going to start coming together. All the little things we've been doing since we got into this chapter are all going to get used together, and we're going to end up getting even to more detailed little pieces that are eventually going to all work together. They all come together to make a big, beautiful picture. But I need you to stay with me without getting frustrated. This stuff, at least mathematically, is easy. You only have four situations to deal with, and you can write them down and make a note of them, see them. The big thing is you don't even compare what the actual numbers are. All we care about are even or odd, positive or negative. For the front number, put it in standard form. Most powerful to least powerful. First exponent tells you whether that's even or odd. Leading coefficient, whether it's positive or negative. In this case, we're having a positive, which means he ends up eventually going up. And he's odd, which means he started off doing the opposite. So he could have just been um, doing that, or he could have been doing that, right? Or he could have been doing there, or he could have been doo-doo. I'm running out of space. Oh, these are not even functions the way I'm writing them. Hold on. There we go. And going off to the edge too much. That. All of those things. I could do that. So now we're going to have limit notation based off of this. You want to do the left side first, the right side first? Well, okay. So you two, I know you said right side, but more people were saying left. They just weren't as loud as you people want to do it the right. So if I'm looking on the left side, that is the limit when x is going to negative infinity. Right? All of this just says, so far all I've said is, I'm looking to see where I'm going, not where I technically am, but where I'm going when x is going all the way to the left. So I'm looking at these left arrows. Not up or down, right? I'm saying I'm looking to the left side, right? For the function, remember, that's just a fancy way of writing the y. The function is going, now is it going up or is it going down? It's going down. So, down. And then we do the limit notation on the other side. Let's look at the right side. The limit, when I'm looking at the x's all the way over to the right, the function is trying to go all the way up. Note, leading coefficient's positive, right side, there we go. Right side limit is positive. That lemon skate, the infinity symbol, is positive. And now, we only have like two things left to write. We're going to get domain, and this is going to be so boring, if it's a polynomial, which it should be in this chapter, the domain's going to be the same every single time. It goes all the way to the left, all the way to the right. Or you can graph on your paper any x as long as the x is real. And the range, we'll look at that too, right? If it's odd, then the range is negative infinity, goes all the way down, right? All the way up. In fact, if the leading coefficient is positive, it actually goes on the left, it goes down first forever. It starts at the bottom of the world beyond. and goes all the way up. Or, that was dangerous to say, any y, as long as it is real. You can get to any y that's real whatsoever. There's a way to get there. Alright? I'm going to make those points in the next one. So, the next thing that could happen is, what if that leading coefficient had been negative? Right? Well, if it's negative, then this guy's not doing that. He's doing this. And this one's not doing that. He's doing this. And this crazy one here isn't really doing that. He's doing that. And this guy over here would look, oop, oop, not a cusp. They're not going to do a cusp. Although they could get really close. Not the way I meant to do that, but okay. Alright, anything at all, as long as they end up going down, and they start off opposite of that. The opposite of down is up. Well, if the leading coefficient is negative, the right end is going to end up pointing down with a negative infinity symbol. And if the degree is odd, this infinity sign is going to be the opposite of that one, which makes it positive. And if it's a polynomial, the domain, it's going to be all real numbers. And if the degree is odd, the range is going to be all real numbers. Well, that's simple enough. Well, let's change one other thing. What if that wasn't odd? I need more colors. What if the degree, I'll write it in purple again, is even? Well, no more of those pictures. That would mean if I finish negative, and if it's an even degree, then I started the same way. I could have an n, or an m. I have a question. If you have a u, right, and then you end up having a second u, they call that a double u. But if I have an n, and then I have a second n, they don't call that a double n. They call that an m. This is why I can't be an English teacher. Alright, there's an m, and now a triple n, or 1, 2, a double M, or a quadruple N, right? If you squint enough, it looks like that. All right, so the limit on the right end, the sign, still going to match that sign. The left end, since it's even, it's going to match this one. Right? Or that one, but we'll get there. Since it's still a polynomial, the domain's still going to be all real numbers. However, now it's going to be a little bit different here. The range, since it's an even function, it has a top. I think this guy's a little bit taller. And that one is the top. And that one's no matter what, if it's an even function, it's going to have either a top or a bottom. And since this guy is negative, it's going to have a max. Negative max, positive min. Alright? There's all types of things, like it's negative if you're told how high you can get. You can't get any better than that. You know, this is your lot in life right here on this graph. Don't expect anything better than that. That's kind of a negative thing, right? You know, it's like 90% of the Hollywood movies out there. You're a pauper boy. You'll never get any better than that. You're the son of sandwich maker or something, I don't know. All right. And whatever it is, it's negative to say you can't get any better than that. And that's how I remember that. It'll stick with you. So, my range is no longer all the way up to infinity. Right here, my range is up to whatever that max is, but I can touch it. I can be the best I can be. All right? So I can be any y as long as I am less than or equal to that max. And you wouldn't actually write in the word max. Eventually, we're going to see what that number is, and we're going to put that number in there. Now, we've done 3 examples in like almost 11 minutes because I like to ramble. We have the last one left. Absolute last thing. What else could happen? And I still wish I had more colors, but I'm going right back to red again. What if that leading coefficient was positive? Are you sure? I am positive. All right. Now, all those graphs are going to be upside down. So now instead of an N, I can have a U, or, see what I mean, a W, or a triple U. Did you see that? That was the scary part of the roller coaster. Or, whoa, oh, 1, 2, 3, 4, a quadruple U. As many U's as you want. Now, since my leading coefficient is positive, the right end limit will be going up to positive infinity. And since the degree is even, the left-hand limit will match it. We don't need all that fancy stuff around it. So it'll also be going up to infinity. Since it's still a polynomial, the domain's going to be all real numbers. This is going to get more exciting and at times miserable for you, at times challenging. Just be grateful that most of the things we've studied so far have had nice domains. There'll be a time that you will long for the day when every answer for the domain was all real numbers. Now the range is different. Now, this is a positive thing, right? It doesn't say how great you can be. It says you have to at least be there. You know, you're the son of a nobleman. You will never get worse than that. Right? That's like a positive, uplifting thing. You cannot do anything uglier, lower than that. Right? I made these too close. I'm going to say that one's slightly lower. But if I tilt this a little bit, maybe it's not. Right? Those are the max, those are the mins. I can't get any lower than that. So now I have to start like way over. Alright? So now I can touch that min. Right? You can be the worst version of you. Don't, but you could. But you could do or be anything. That's like a positive message. You're, no matter what, you're human. Right? You can't be worth less than that. And then, but because you're human, you have, the sky's the limit, unless you want to be an astronaut. Then the galaxy's the limit, or whatever. I don't know how far out we could get. So any y, as long as y is greater than or equal to whatever that minimum value is. And that is pretty much everything you can see for this stuff. Limit notation, domain range. We even put some sketches in there. And all based off of what the leading coefficient is in the degree. And you guys have gotten, those of you that have been doing your work, have been getting pretty good at finding the leading coefficient in the degree. If you can do that, you can pretty much nail the big picture. Sorry, you can't see my hands. The big picture graphing stuff. All right. Be awesome. Do well. I miss you all. One day we will see each other again, and I will say, I don't remember you. Were you in that virtual class thing I was in? Okay.